Good evening, everyone. Am I audible?
Yes, ma'am.
Good evening, everyone. Welcome back to day 3 of Data Camp workshops. Today, um it is my pleasure to introduce today's distinguished speaker, Dr. Abhijit Gupta. Dr. Gupta, an associate professor of Department of Physics at Pashkura Bonomali College, with over 26 years of teaching experience. This college is an autonomous institution with both undergraduate and postgraduate courses. Dr. Korgupta also worked as visiting professor at Nalanda University, Rajgir, Ashoka University, New Delhi, and West Bengal State University. Beyond teaching, Dr. Korgupta has a great research portfolio. His primary research interests lie in computational physics, statistical physics, and interdisciplinary applications of statistical physics. He published so many articles on pedagogical and popular science in some Indian magazines and journals. He has actively engaged with the academic community by attending and delivering lectures in nearly 50 workshops or seminars on Python computing and AI related matters, conducted by various research institutions, universities, and colleges in last few years. In addition, Dr. Kaur has authored so many popular and widely appreciated books like Scientific Computing in Python, Python Computing Fundamentals and Applications, Understanding AI, a beginner's guide to artificial intelligence. So without further delay, may I now request Dr. Abhijit Kargupta to kindly commence the session. Sir?
Okay. Thank you, Promita ma'am. Hi, everyone. I guess you can hear my voice. Let me
Yes, sir.
share my screen. Okay. You can see my screen and you can see my voice, right?
Yes,
Is that
sir.
okay? Anyone
Yes,
will
Abhijit.
respond? Okay. Please tell me whenever you cannot hear me or see me, or probably I can later uh, close the video if the transmission is not good. Anyway, so let me begin. Before I begin to show you about real data and how to handle the real data with Python and to how to visualize those data, that all these things are extremely necessary for your present day research. Presentation is very important, and handling data with Python is very important. Even you are doing with some AI app, basically, if they most of the time they will give codes in written in Python. So if you know a little bit of Python, not much, you don't have to do much coding in Python. But if you know a little bit of Python, that will be easy for you to handle those things, to control those things. Okay, and you can create beautiful idea and beautiful visualization things from your data. Okay, and then you do modeling, etc., etc. Okay, before I begin to show you the real data and things like that, I'll just remind you about some little bit from where Dr. Ornavo Odikari left the last day. He was showing NumPy. NumPy is a package in Python, external package. So the principle is in when you are working in Python, whenever you are using any module or a package, external package is nothing but you can treat it as a module or a module of modules, basically a collection of modules. Okay, so you import that, right? Import NumPy as say NP. That's what you did. I'm just showing this on Python interpreter. Later I will move to Jupyter Notebook. Okay. So numpy is here in your name on your working space. This is called namespace. Okay, and the two things you remember. One thing is that since if you have no book, no one to support you, you are doing Python or doing something with Python. So this is the package you have already installed. You have taken here, brought here, okay, on your namespace, and local name is np. You can just see what is inside that dir. Remember this function dir. Python most of the time you'll see all kinds of functions. You can manipulate things with all kinds of functions, all kinds of inbuilt functions, all kinds of functions in different modules and packages and things like that. Okay, and you see lots of things here. Okay, you see lots of names here, lots of names here. Some are submodules or module, and some are functions. Okay, suppose you want to see this sum. This sum you have encountered in normal basic Python also. Here is also you have sum, you have all kinds of things. So what you want to know how this, what this name, what is this behind this name? Okay, so then you write help, and then you have to give np dot sum. Okay, that means the sum is the name coming from numpy, that means np, and you don't know what it is. Okay, maybe it is a function, maybe it is a module. You don't have to know, just check, and you check that. Okay, and you see this manual, and you try to read the manual, not all, but see the sum, of course, sum of array elements over a given axis, of course, array over the short, and A is the, suppose you give the array, and so sum over array, it will give you the answer, sum of the array, and then you will see lots of switches here. These are called keyword arguments. That means some name equal to something. Here is the normal argument. Any function, you have normal argument, and other are special arguments. Those are called, those are under some name. Those are called keyword arguments. So axis, you can give some axis, you can give some data type, you can give some other names, you can control the switches. If you don't give, you will get something. You will get something normal things. Okay. Okay. So these are the two things. One is dir, that is the directory, to see the directory. Another is help. So whenever you are doing anything with Python, you just remember the two names, dir and help. Okay, and remember when you are doing anything in Python, there is a basic Python, right? There is a basic Python. There is a basic Python. And then after that, there are some modules. In the basic Python, there are around, say, of the order of 300 modules. Modules are there. Lots of modules. We know only some modules we use. Math modules for mathematics, CMath for complex mathematics, random for random numbers, and some other. Okay. But there are more than, and this is basic Python only. And then there are around 55 to 60 million other million, remember 1 million is 10 lakhs, million other external packages and modules, and it is growing every day. It is growing. So there are many endless, really endless number of external modules and packages. So it's a Python community is a huge community nowadays. So among all those packages, suppose you are working in biology, there is a group, they have made BioPython. You are working in geography, you people have made GeoPython, and then the GeoPandas and things like that. Then people are working in cosmology, CosmoPython, and then there are so many modules, lots of different packages, and then there are company packages also. I am talking about only academic things. Okay, and if you if you want to understand, I mean, you don't have to understand all those packages. Some packages will be useful for you whenever you need some package. Suppose you are in geography, you want to do map, you want to draw map, there is this package. You just install it, and then like NumPy, you import it, see what is there through the dir, and then check some names, what you can do with those names, see some examples, look at the manual, and proceed. All in the same way. You don't have to remember anything. Just a fundamental thing is that dir and help. Okay, and of course, whoever have consulted my book and whoever have consulted, who have done anything in Python, they know there are a few external packages like NumPy. It's a most fundamental package, NumPy. NumPy is numerical Python. So it handles all the different dimensional arrays and the mathematical functions which are vectorized, means you do operations on each of the elements of the arrays. Suppose you have a sine function or exponential function, you put the array inside that exponential or sine function, it will be exponential of all the elements. So it's a vectorized array and higher dimension vectorized functions and higher dimensional arrays. So NumPy is the father of all those things that handle numbers, and the Google's these things, all these AI packages and everything, all kinds of packages are based on basically the fundamental package is NumPy. Then they develop lots of other packages based on this. Okay, and then for us scientific people, we have SciPy, scientific Python, where all these special kinds of mathematical operations, special functions, lots of different calculus, and all kinds of linear
Abhijit,
algebra, all kinds of things can be done with
Abhijit,
SciPy. Okay. Anything you are saying, Kishore?
Abhijit. Yes,
Huh.
Abhijit, can you hear me? Can you hear me?
Yes, I can hear you.
Actually, a pop-up window is blocking your whole screen. Pop-up window showing the images of the
Pop-up window.
participants.
Okay,
Can
okay, okay,
you?
okay.
Yeah. Can you?
Is
Can
that
you?
okay?
Yeah, yeah. That's fine.
It's okay. It's okay. Unfortunately, I have upgraded my machine, so I cannot hear the other voice properly. I have to adjust the sound. I did, but it's not working. I have to check it. I didn't have time. So whenever anybody one is speaking to me, trying to speak to me, please be louder and take your mouth in front of, I mean, closer to the microphone. Okay. Anyway, NumPy, SciPy, and then there is for visualization, there is a matplotlib. Matplotlib, you can say mathematical plotting library, or MATLAB, people who have done MATLAB style plotting library. And of course, for real data, structured or unstructured data, that Dr. Kishore Mukhopadhyay said first on the first day and showed some overview. That is the package called Pandas. I will show you that. Okay. Mostly these four fundamental packages, those are very, very important, and whoever is doing Python, you will encounter now or anytime all these things. So this is for arrays, this is for scientific calculations, this is for plotting 2D and 3D graphs, and this is for structured and unstructured data, all this real data. Okay. Okay, so these are the four things, but the using them and using the packages and trying to do something with these packages is the same. Check the, if the package is already installed here, you just check the directory, bring it to your namespace wherever you are working, check the directory. If you have forgotten the names, check which name you want to use, something, some module or something. Suppose you are trying to do linear algebra. Okay, maybe there is a name you can see, linalg. Okay, go to linalg. So np.linalg. Go there and check. Okay, maybe you want to do some eigenvalue, solve some eigenvalue problem for your thing. Maybe you want to do some principal component analysis or something, maybe matrix multiplication. Go there and check what are the names there and how you will use that. So you don't need any book, you need any tutorial, don't need any tutorial, you need not ask anyone. You have the weapon at your hand. Okay, so thus I begin to show you the real data. Okay, here is my computer. Here is on the desktop. I have a demo directory. Here I want to show you a real data. Real data, real data. Okay, sometime long time back, I just downloaded data from during the Corona time. I had nothing to do, sitting at home. So there is this is an Excel data. Many people have done worked with Excel sheet and let it open. So this is the data. Okay, you may or may not see all the names. I can read for you. Here, the first column is the name of the provinces and the something something, and the second name is the country. uh, this is latitude, longitude, and then the corona affected, how many number of corona affected people. Remember, this is 1/22/20, that means 22 January 22. It started from here, and these things go here, and lots of this. So all these columns are the dates, and this is latitude, longitude, that means on the position on the globe, name of the country, and this is the before the first column. So this is usually the serial number, default serial number. Okay, so this is some example Excel sheet. This is a real data. Actually, I downloaded from, at that time, John Hopkins this site, university, this site. They were regularly updating long back, but I use this data for demonstration. So this is the data. This is an Excel sheet. Well, and what are there in Excel sheet? An Excel sheet, you see, this is real data, and this is structured data. And you see there are lots of what you can expect in it, in such a spreadsheet. You see lots of numbers, but also you have some lots of different kinds of numbers. Dates are given in a certain slash slash something like that, and then there are some names. Maybe in some places there are there is no data, or maybe somebody has scribbled something there. Suppose these names are these spaces are open. I mean, nothing is there, empty. So Python can handle all those complicated and real structured data. Of course, also unstructured data like your image and things like that. Okay. So the clever, the pandas is the software. Pandas is the Python external package, which will read this and give you back something. You can, and the all these Excel sheets, either you can directly read, or you can save it as a, when you save it, you save as something like that. It will save as okay. I'm not going to save it now because it will create problem. Okay, you can save it as CSV file. CSV means comma separated value. You can read it. You can save as, sorry, CSV file, comma separated value file. All those files are basically CSV files. I mean, of course, there is not always comma. There is a gap. There is can be semicolon. There is a colon. There is something. But these files are called CSV file. Okay, and the pandas in Python can handle those things, any kind of data. Okay, that's amazing thing. Okay, so let's okay, minimize it and go to the real data. Okay, let's see that. Okay, so Excel sheet as data. Okay, here I am now at in the Jupyter notebook. You have seen Jupyter notebook already. So okay, let's see. First step, the setup and data loading. Well, what are the packages you need? Okay, of course, pandas you need. Okay, can you see that? If you don't see that, please tell me. Okay, import pandas as usually we call PD. Okay, and of course for visualization later, we have also imported matplotlib. and not the full matplotlib, but inside that there is a pyplot module which is actually specialized for 2D graph. I want to see 2D graph, not 3D at the moment. For 3D, I will do later. Okay. So matplotlib you have actually imported here, and not matplotlib. This pyplot under matplotlib. This is the you see. This is the special way of referring names in Python. Something dot something dot something dot something. That means you are taking from something. That something is inside something, and so on. So matplotlib.pyplot, and you give as a local name plt. That is usually we do. It's a customary. Okay, you can give any name. You can give a name like Roshagulla or whatever. So as is a green, as is a Python keyword, import is a Python keyword, and so on. And then there is another app, another not app. I can tell you this is basically another external package which is called Seaborn. This is very popular with all these data science people, because Seaborn can do sometimes fancy stuff that not all other visualization packages can do. And there are lots of thousands of visualization packages. And of course, Seaborn is made over Matplotlib. That means Matplotlib is the fundamental. Okay, Matplotlib is very powerful. You can do animation, you can do image processing, you can see do 2D graphs, you can do 3D graphs, you can do lots of things with Matplotlib. Okay, but still people have done Seaborn. I mean, they have made Seaborn, some other companies, all free, all are free, and all are open source. Okay, so import Seaborn as usually we give a name SNS. And then of course, NumPy will be always there, because anytime you want to handle the array, normal arrays, 1D array, 2D array, 3D array. 1D array is a vector, 2D array is a matrix, and 2D arrays one top of the other. That will be 3D, it's a box or a tensor or a 3D matrix, whatever you call, but image is a 3D array. Video is a 4D array, and one image, Kishore mentioned in his talk, one image, and it is time with time. That means one 3D array is moving in time. That means another dimension. That means 4D. And then there are packages. There are arrays in 4, 5, and other all dimensions. Okay. So let me now run it. As long as this is star, that means it is working. Don't move. Just wait. 1, 2, 3, 4. I need these 4 packages for my next demonstration. Okay. Okay, done. It has given me a number and silently passed it. So the setup is done. I need these 4 packages. And for your demonstration, I can, for a fancy demonstration, I can use this style.use file function. It's a function actually. It is under PLT. What is PLT? PLT is this. That means matplotlib package I am using, pyplot I am using, and inside that pyplot there is a function called style.use, and I give this quote unquote dark underscore background. Okay, let me run it. Okay, done. The style is also set. I'll do it in my style. Okay. Okay, you can ask me later, wait, how do I remember all those things? You don't have to remember. You just go there, search there, find something, just make it a Jupyter notebook. Later you use see some reference or Google, just Google. Okay, now the data. So data is here. Okay, time underscore series underscore 2019, this big name. Okay, 2019 ka data. Okay, so you are reading with read underscore CSV. I am here in this, probably in this demo direct folder. That's why I have not given any path name. If it objects, then I will give the path name. Okay, how do you see the path name? Suppose you have a file here, right? Suppose you have a file here and you see the file. You want to see the path name. Just right click You know all those, right? You just right click, properties, and see this is the location. C colon users, my username Abhijit Gupta, then desktop this name. Okay, you can just directly copy these and put it there before that. Okay, you don't need now. Okay, now this is let me download. Downloaded. I have not given any path name. It has downloaded because I have changed and this file is in the demo directory. So I am in the local directory, no problem. So data is downloaded. Let's see. And I have given the name df. Okay. So this is the name of the variable. Okay. This is read underscore CSV is the CSV file reader in PD. PD means pandas. PD means pandas. Okay. And it has read. So what it has read, let's see. So I have given the data. This is the data, and I have given the name some variable so that I can refer it and I can use and reuse it. Let's have a quick look. What is the data? Okay, the data shows like this. So you see, this is no more an Excel sheet. This is some display. Here I am doing inside Python. Okay, this is Python property. So it's a Python object. Actually, the name of this, I have given a clever name so that you can remember. DF is data frame. Like NumPy array is a kind of object. DF is a data frame. So you see all the columns and everything is there, but it is displayed here. You see all the empty spaces, it has cleverly written NaN. That means it has handled the empty space as had written not a number. That means whenever I search with Python, that wherever there is nan, you just remove that. Okay. Otherwise, I cannot say wherever there is empty space, remove that. That is difficult for a computer programmer. But if I say it has given some name, empty space has given some name n. Even there is something. Some object, something is sitting there somewhere. Somebody has scribbled, somebody has written some name, or somebody has signature, or somebody has written something, male, female, or something that this machine cannot understand, this Python cannot understand. It will immediately write there NaN. So NaN is good for us. We can understand that there is something unusual is there. Okay, and these are countries, latitude, longitude, and the dates and the numbers. So the file it is showing me. It's a small file, 501 rows and 6 columns. Actual big data is by thousands of columns and thousands of rows. I mean many thousand, maybe 50,000, maybe 1 million or something like that. So for that, this Python and pandas in Python is extremely important, because no other language can do this such well. Okay, so this is called data frame. Let me go to tell you what a data frame is. First, I'll tell you what is a data frame. Okay. So, well, I just wait before it comes. Jupyter, it opens a new notebook. Why it's not coming? It's sometimes slow. Lots of things are there. Okay, why it's not opening? Okay, anyway, I did something here. Okay, and let's show this. Okay, so I was trying to see how I can present, but I was impromptu. Okay, here it is. Okay, so let me import NumPy as it's a new Jupyter notebook I have opened, and import pandas as PD. Okay, let me do that. Let me why let me pandas. Sorry. Okay, so now I am using NumPy. Okay, so if I use NumPy, inside NumPy there is say called random. Suppose there is a random function is there. Okay, random module is there. And inside that there is also a random function. So inside numpy there is a random module, and inside there is a random function. Some sound is coming, some audio is open. Is this problem? Is there any problem? Some audio is open. Can you please put off? Okay, so random, and now the random, I mean, if you want to know what this random thing does, you can check again within help. You can write this name. Some sound is coming. Uh, anyone is saying something?
Dr.
Anyone is saying
Apurva Kumar
something?
Naik, Dr. Apurva Kumar Naik, please mute your mic.
Promita, and anyone is saying something?
No, sir,
I cannot hear
No,
properly.
no, sir,
no,
no,
sir.
sir.
Okay. Let's see that. So random.random, random this is the module name, and inside the same name there is a function, and it generally it creates random numbers between by default 0 to 1. And if you check it by help, you can see all those things. I'm not showing it now, and you can give it a size. Say suppose say 4 by 5. Okay, now I have created a 4 by 5 random matrix, 4 rows and 5 columns. Okay, and these numbers look so big, so I can use another function np dot round, and I can put everything inside that. And this entire thing I'm putting inside np dot round, what it does, it rounds off, say up to 2 decimal points, say comma 2, and give it like this. Okay, so this is the matrix 2D array I have created. Let me give it a name, say suppose data. This is my say fake data. Okay, this is a fake data. Let me check and again the data. So this is a 2D numpy array. Now if I put this inside pd dot data frame, inside that data, what it looks like. See, this is data frame. So I am using capital DATA, capital frame. So that means the same thing. This array has become the decorated one. That means why it is decorated? Because it has given the automatic, the row names 0, 1, 2, 3, and the column names 0, 1, 2, 3, 4. Okay, and if you see the help, if you see the help inside, you can write pd dot data frame. You can immediately see what are the other things are there, what are the other keyword arguments that you can do, right? Index, columns, and all those things you can see. But you don't need that. I can put this, right? I can put this, say suppose index equal to, say, how many index is the row indices, 1, 2, 3, 4. Suppose I put it right, say something like, say for example 10, 20, 30, 40. Okay, and I check that. Okay, you see the index numbers 10, 20, 30, 40. Then I can give the column numbers. Here the keyword argument is columns, columns, and I can give the, say suppose A, suppose B, C, D. I'm sorry, because these are the names, these are the some alphabets, so I have to give within quote unquote. Okay, and you see, you recognize this, right? This is a list of numbers, and this is the list of strings, right? If I see this, run it, you see A, B, C, D, E, all these things are on this column names. So this is the now decorated file. This is the now stocks. I mean, real, looks like a real data. Okay, you can give fancy names and things like that. You can prepare a table. Then you can make this data into Excel file. You can create an Excel file from here. Okay, by writing Python commands. Okay, and so suppose I give it a name, so DF. DF is data frame. I can give any name, but DF is handy. Okay, so now you see the DF, and the DF is data frame. You can also make it again back to NumPy array. Suppose you know how to handle NumPy arrays. This is easier for you. So I can make, there is a function called df do dot, I mean, inside this df, method of df is called to NumPy. You don't have to remember all those things, but once you start working with data, you will know what is what. You see again, so df is the data frame, and the data frame is converted to NumPy array again. Okay, so these things are very handy, very useful. Now I'll show you one more thing. Let me import matplotlib.pyplot as plt. Okay, let me import this matplotlib. Okay, before I go to real data, I'll just give you just shadow practice. Okay, so plt. So if you want to see what is there in plt, of course you can see dir plt. It's a huge thing. Okay, you can actually print, and here you can write print, and you can see all those things. Okay, all these names, and of course there is a function called plot. You can plot two these things. Okay, maybe let me show you that maybe this is the data. Okay, this is the zero. Maybe you want to plot this column versus this column. Okay, this is 0th column, this is 1th column, this is 2th column, and this is df to NumPy. You can call it, say capital D. Let me give it name to capital D. Okay, and you can do this. Okay, let me cross it. Okay, you see, if you know slicing, if you have a data file, and if you know slicing, that means you take out one particular column or a bunch of columns or a bunch of rows. You can do that, right? That is called slicing. So if you write, say, D, suppose if you write D0, it will give you just this first row, right? This is first row. Okay, it will give you the first row. I mean the 0th row. If you write D1, it will give you the 1th row. If you write 1, 2, 3, that means it will give you 1 and 2, right? 3 is this is the start, this is the stop, and by default the step size is 1. You don't write step size 1. It is by default. Okay, so it's the same thing. Okay, but now for columns, you have to give another set of columns. Suppose you want to take this and this. That means 0th column, it is 0th column. This is 1th column, this is 2th column. So you write 1, 2, 3. Okay, and you can write 1, but you don't have to write just 1. This is by default, step size is 1. So you see this. But if you want to have extract the full column, that means all the rows, right? So here you give just colon this. You write, see, you have seen that. And suppose you want to extract this only this 1th column, so then you write only the 1th column. See, if you want to extract the 3rd column, I mean 1 to 2nd column. So if you want to write 2nd column, this is only the 2nd column. Okay, so let's say X data is your D colon and 1, and Y data is D colon comma 2, right? So X and Y are prepared. So if you want to plot plt dot, inside this plt module, there is a function called plt.plot. Okay, and if you just give X comma Y, it will automatically plot. It will automatically plot something. So it's a random data. So it will plot. It will, suppose you plot with bullet symbol, it will plot with bullet symbol, and all that. Okay, So this is how you plot all those things, and you can visualize data immediately. You can have data, you can extract the data, and you can visualize all those things. You have lots of other functions. For example, you can write plt dot scatter. All those things we will use x dot y. That means it is by default scattered data. I mean, by default, this is all we'll put with this gola. Okay, these things. I can plot this outside in another window, but at the moment, for going over to just decrease the, I mean, kind of harassment, decrease the kind of trouble. I am just showing it here only. Okay. Suppose you create one data. So suppose you create suppose you create some x. I mean something, some d equal to something np dot random dot say normal. Okay. Now this time I was using normal function. Normal function will create random numbers taken from normal distribution. Okay. So suppose you are creating using this normal, and if you go inside the normal function, how you will see, first thing is the mu. Mu means the mean. Normal will be based on the mean mu, and then you give the sigma. Sigma, suppose I give 2, and you create, say, suppose you create 1 lakh data. Okay, 1 2 3 4 5 6, yeah, 1 lakh data. Okay, and you see the data. So I've created this data as a dot 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 dot. So I've created 1 lakh random numbers, taken from the normal distribution, whose mean is 0, and the standard deviation is 2. Suppose now you want to, I mean, suppose you have some data, you don't know where from it has come. You can do lots of things. You can check what is the minimum number, what is the maximum number, what is the standard deviation, what is the mean of all those numbers, etc., all those things, variance of that, median of that, mode of that, etc. And also you can see how the data is distributed. So visualization is very important. You can see the distribution. Immediately you can use plt.hist. Remember, all those things are happening inside Python. You don't have to go out Python language to call other some software to plot. Everything is here. So plt.hist, inside that you write, say, d, this data, and now there are lots of keyword arguments. Usually it takes, suppose, some 10 beans or something like that, as far as I remember, but you can write, say, beans number equal to 40. You can give 40 beans. You can give h color equal to, say, black. You can give some color equal to say yellow, y for yellow, and so on. All these switches are all will be, you can see, go to plt, go to hist. This you can see all those things. Okay, every function you can check, every function you can use, and in the same way. Okay, let's see. Okay, unnecessarily these are giving you all those beans sizes and and the frequencies. I don't want that, so I put a semicolon here. So directly it will give you it will show you the distribution curve. You see the distribution curve. That means the data are taken from this normal distribution. You can see, check. So this is known, this is fake data, but if you have data, you can do lots of things. Before you go to serious statistics, before you go to machine learning, you can deal with data. I mean, you can check what this data is, where from it is. I mean, what kind of data it is, what is the distribution. We want to see the distribution. Distribution is very important, particularly in social sciences. Everywhere there is a normal distribution. Okay, so you can see that. I can show you another fancy stuff. Suppose I want to create another, suppose A is some data, and I want to create np dot random dot normal 0, 2, And now this time I've created 2D, I mean 2D array, okay? So size equal to say 100 by 100.
100 by
Suppose the
100.
data is in the form of 2D array, or if you have a 1D array, you can reshape it in 2D and check what kinds of data it is. Suppose, oh,
Error এসেছে
oh
জাস্ট
yeah, 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 you have to complete it with
আচ্ছা এটা ফার্স্ট
this thing. Uh,
দুটো
uh,
হয়ে গেছে স্টার্টিং হচ্ছে এন্ডিং
oh, okay,
হচ্ছে
okay, okay. I'm sorry. It's okay. It's okay. Let's see what A is. So if you see the data, this is ugly, something ugly. You cannot. It is no way you can see something, right? You can make a distribution and see, but there is another fancy way you can see. PLT dot inside the PLT. I mean, I told you that these this matplotlib is a very powerful package. Here you have all this stuff of uh, data visualization, 2D, 3D, contour plot, this thing, that thing, statistical plot, all kinds of animations and image processing stuff. Of course, in Python there are other modules which can do image processing, but this is one package is for many things. Okay, so now there is a function called imshow.
ইনশো
Put a inside that. Check what it is. Have you seen something? Some graph. Now, what did you understand? Okay, let me put it plt dot what is called bar, right? I think bar. I think bar. No, no, not bar. It is called what I was doing. What is called? It is called color bar, right? It is called color bar. C O
কালারটা মুখস্থ হয় না
L
মুখস্থ
O
করার পরে
R
যখন
color bar.
জিজ্ঞাসা করবে
Okay, let's that. Okay, now you can see what you see. This color bar has the values. It shows you the 0 is green, right? And the this side yellow is 8 and the blue side is -6. That means data and the numbers are distributed between, say, suppose -6 to +8 or -7 or -8 to +8, for example. And in the middle it is green. That means you see the picture. What do you see? The picture, most of the colors are green. That means green color is maximum. That means if you see the color, the middle portion is maximum. That means you will understand, if you want to see a distribution, it will be something normal. That means middle green is maximum, yellow is very less, blue is very less. You see less blue, less yellow, but many green. So this is, if you see such a picture, you will understand. We photographers, so whenever we take a picture, just looking at the picture, we'll understand from our own experience that what are the the dominant colors in these pictures. Then we can go to the Photoshop and things like that, and we can see the distribution, and we can see the color distribution in the form of curves and so on. We can understand how many colors, what kinds of colors are dominating, how do I change the picture, tone of the picture, so on. Okay, so this is this. Now I can, just for comparison, I can np dot random. Quickly I go to real data, random dot say uniform. So this is uniform is something creating numbers from, not uniform, maybe random. Say random automatically creates numbers between 0 and 1. Okay, or maybe uniform. Uniform, and it creates numbers. Try to create numbers between -1 and +1, and size equal to the same size, 100 by 100. Okay, so now see these numbers. Again, if you see the numbers, you will hardly understand anything. All these are numbers, ugly numbers. But now if you do the same thing, plt dot what? Imshow, right? Imshow. And B and plt dot color bar and this. Okay, now see what happens. Okay, you see now. Now you see. So this is a uniform distribution. You see the green is middle, 0. And the yellow is this side and blue is this side. And you see this is a well mixtured green, yellow, blue. That means it is a random. Okay, you see the picture and you can tell immediately, see this is a normal distribution and this is the uniform distribution. So seeing the picture, you can understand what kinds of colors it can be, what are the distributions of the numbers. Each color, each pixel carries a number, right? As Kishore told me, told that day, that first day, that the pixels are the intensity of color. It goes from 0 to 255, right? So you make three sheets, RGB, okay? Each pixel is coded between 0 and 255 because 256 is the number, 2 to the power 8, because each thing is represented as a 8-bit number, okay? So that's why it is this. Okay, now we go back to real data again. Okay, any question, please tell me. So you understand that this is a data frame which is based on NumPy array, and you can see this data frame this way. If you want, you can convert it to NumPy array if you are comfortable, or in the data frame, you go to and check help data frame and you see lots of functions are there. You check dir inside data frame, you see lots of names under data frame which will help data frame to manipulate. Those are called data frame methods. Like there are NumPy methods, there are list methods, there are tuple methods, there are string methods. These are specialized functions, okay? Now if you go here and you check the data frame, now you can also see this is one method which will show you only the head, not all the data. Suppose it is showing you 5 data. I want to see 2 data only, first 2 data. Suppose you have a huge data file. I want to see only two rows. Okay, I can see that. Suppose I want to see the tail of the data. Suppose the tail, I want to see last 3 tails. So I can see that 3 tails for 498, 499, 500. Okay, last 3 rows. Okay, now before you go to do any modeling, before you go to do visualization, you want to clean the data. Suppose data has some bad elements, data has something unwanted things, data is in some form which you don't want, it has some names which you want to remove, etc., etc. For example, here you have the 2 columns, the first 4 columns, province, country, region, latitude, longitude. All these are, I don't want to plot. Suppose these are the real data that I want to. These are the, starting from the 5th column. This is the automatic. 0th column is automatic. Province, country, latitude, longitude. The 4 columns you want to, suppose, for the time being, you want to just keep aside, and you want to see the the columns on different dates. Okay, so you have to clean that. You have to slice them out like a NumPy array you did. Here also you can do that. Okay, so don't worry, everything will be very, very simple if you understand the basic principles. Okay, the data preparation and cleaning. Suppose see data and see df is the data frame that I have shown. Okay, and if I show you that df dot columns, that means it will fetch you the columns, and I write 4 colon nothing. That means it will actually start from 4. It will begin from 4. 0, 1, 2, 3 are kept aside. So it is slicing, it is starting from 4 and colon nothing. That means it will go up to the end. So that I have written here date underscore columns. So some variable name. And then latest date. How do I see the latest date? Date columns ka inside you write -1, because if you count from left side, if you have some 2, suppose 2, 3, 9, 5, 1, 0 or something, So these are the numbers, right? So if you want to count it, so here you begin from 0, 1, 2, 3, 4, 5, and if you come from left right side, this is -1, -2, -3, and so on. This is a number line. This comes here, right? If you want to understand this. So the last entry is -1. Okay. So here this is -1. So latest date you can get it. And here I have unnecessarily written one uh, logical statement. You don't need that. I want to tell, okay, maybe the data is coming. I want to, maybe the last date is not complete. I want to just, stop before that. So I have written here -2. But that's not important. Let me, okay, but let me run it. You can do it in your own way. In your own, okay, where it is, I'm running it. Okay, so data super, there is no much of data preparation and data cleaning. Here it is very simple data. So only discarded the first 4 columns and so on. And the reality check. If you have a data file and you have loaded it as a data frame, you can see the reality check. Reality check means you can do basic statistics. You can, at one go, there is a function called describe. It will give you mean, median, mode, percentile, this thing, that thing, all these things really give you. Okay, you can check particular distribution, you can check everything. So next thing is say reality check. You see that. See global sum, average cases, median cases.
Abhijit,
Yeah. Anything you are
Gupta,
telling?
yes, yes. One thing, can you briefly discuss why data cleaning is necessary for the audience only?
Data
Because
training, data training.
data cleaning.
Oh, data cleaning is necessary.
Mm,
Yes, yes, yes,
Yeah,
yes.
yeah,
But
yeah.
data cleaning means nothing but you have a data, you have a set of data. Sometimes, because if you want to do data science, you want to do machine learning. But in deep learning, you don't need. It is so clever, it automatically cleans. But up to machine learning, up to normal small language model, or data science, or big data handling, or normal thing you do, cleaning is always necessary, because you have a data and your real data, you have lots of things there. I mean, I already tell you that inside the data, just I showed you, I mean, I just showed you that you have 4 columns. You have 4 columns where you have these, yes, you have this written province. These are some names, right? Some nan, something is there, because those are entry, and then the country name, then the latitude, longitude. These columns you don't know the need. And there are other fancy stuff, like the data is in something that you want to normalize it, or there are some male female name, you want to recode it by 0 1. 1 means male, or 0 means male, 1 means female, or something like that, so that the computer can understand, because computer can understand only numbers, no alphabets. You give it quote unquote, that's a string, specialized way, but you cannot do mathematics with alphabets, right? You have to do mathematics, all kinds of stuff with numbers. So the whatever data you have, whatever clumsy data you have, because whenever you are taking data, you don't know. Whenever you are getting data from somewhere, you have no control on them. They are not giving data the way you like. You, maybe one column is not necessary, you have to subtract it, you have to remove it. That means that is a part of cleaning. That means you have to slice it. Okay, but and the represent the data in some other way. Sometimes in we do it some kind of coding, like a machine learning. We hear of the names, one hot coding, this thing, that thing. That means you represent data in terms of some numbers, either 0 1 or something, or position wise name, given some numbers or something. Okay, so you do lots of numeral things. I mean, you convert everything into numbers. That's one thing, and organize these things. Okay, for your purpose. it dependent on whatever you have a huge sheet of data that is dependent on what you want to do. Okay, so here the cleaning is a very simple thing. Only I have, this is a part of cleaning. I have only discarded the first four columns and it tried to see the last column. And here is a Python code which gives you is a loop, logical loop, where I have gone up to the before the last one. But you don't need. Suppose you go up to well, this is unnecessary for you. Okay, I don't want to. I mean, tell you to concentrate on this. Okay, now this is part of it. Now reality check. Lots of functions are there, group by, some cases, etc., etc. But you don't need to consider concentrate on all of these things because lots of things are coming here at the moment. You can later check and things like that. See, suppose I wanted to see global total, how much, mean cases per country, median cases per country. I wanted to see mean, median, and global total, etc., etc. This only thing. But I wanted to. I could see standard deviation. I could see some correlation. I could see something. All this basic statistical stuff can be immediately done within this data frame, within these pandas. Okay, there are methods inside these pandas. There are methods for pandas data frame which can give you at one function. I remember describe. If you write df.describe, it will automatically, you can try on your machine. It will give all this case summary, all this statistical summary it will give. Okay, so that's the thing. And apart from these, you can convert this data into NumPy array, and then inside NumPy there are lots of normal functions, statistical functions are there. Then there are very specialized functions in SciPy, also in NumPy. Lots of ANOVA, this thing, that thing, all kinds of things it can do. T-test, chi-square, etc., etc. Then there is stats module is also there inside Python. Lots of things are there. There are multiple modules for the same thing, or to do it in a different way. When you work on Python, you will see as you are in a basically in a garden of lots of magical functions. You can use this thing, that thing, lots of fruits all around. Okay, you can take these, you can take that, represent your data. I mean, some kind of normalize your data, etc., etc. Okay. So now the train, now the visualization part. Okay, and see lots of names. Okay, this remember this PLT is from matplotlib. Matplotlib, import matplotlib.pyplot as PLT. Inside that there is a figure, function figure, and it can give you the figures. You can give figure size. I mean the ratio 12:6. You can plot this global daily dot index versus global daily dot values. Okay, then you can set color, marker, etc., etc. You can do, and then you can put sticks, x sticks. Then you can put title. Then you can put Y level. Then you can put grid, and this alpha is the opacity, this visibility. Okay, and the this you see the x sticks. You will see this rotation equal to 45. That means the dates will be written in a slanting way, 45 way. All kinds of fancy stuff you can do. I mean, you don't have to remember anything. You want to create a production quality visualization graph. Go there and find out, and you see everything is governed by all those functions. Figure is one function, plot is one function, xsticks is one function. Anything you do by function. Why there are so many functions? Because you want to control each of the thing. You want to create a beautiful graph, and the graph has lots of things. It will have title, it will have x-axis, x level, y level, text, inside legend, then arrow, then grid, then color, then the line width, then marker, this thing, that thing. Lots of things you can do. So everything you can do with all these functions. If you forget all those name of the functions, it's better to forget, because whenever you do something, I can give you this Jupyter notebook sheet to you. You can check, but it's better you build your own and from the scratch, and I mean, it takes only just half a day or some 1 hour or two for you to understand how it is working. Okay, because you use the functions, you use all these functions, you now control everything. in Suppose you know Python, a little bit of Python, you don't have to, you don't have to understand everything. You don't have to understand, don't have to write full Python code. You are not writing Python codes, you are not a programmer, but you are a researcher, you are using that. But instead of menu driven softwares, if you use this, like all these instructions by your hand, these things are under your That's the thing I want to. It's not that I'm preaching Python, but the thing is that I know how easy it is. It will be for you to control everything. You see the lots of, see, these are plt.plot, and this is nothing but the x data. This is the y data. X versus y plot. Color is cyan color. Marker is O, that means Gulla, and the marker size is 5. Line width is 2, usually line width is 1 by default, and these are all keyword arguments. This is a keyword argument, 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 and the rest of the things are this, and these are normal arguments. These are name of the variables. I could give some x and y, but to when you write a big code, this kind of, these things, instructions, it's better always that you write some explicit names as a variable so that you can later find out. Okay, so now let's run it. Let's run it. Okay, it is running in star, and you see what is these things. So you see the dates. You can see the dates. The dates are written in a slanted way. Why? Because I have written it 45. That means it is slanted 45. Okay, and I have written colon 7. That means I have not plotted all the data, because there's lots of data. So I have written here global daily index. This is ticks. Ticks are not everywhere. The ticks are at colon 7. That means start and then end by default, but the step size is 7. Okay, I could write it as, say, 10. I could write it, say, here I could give it a rotation, say 90 degree. So you see the difference. You can see, discover yourself. You can discover yourself. Okay, you can just change. You see this date. You see 90 degree, and you see these are 10 space, right? These are 10 space. Okay, 7 is because week, every week. So that's why I give 7, and so on. Okay, and then you can change the colors. For example, you can change the color, say red. So for example, so it will be red. So you can create a fancy stuff always. You can visualize your data. See, it's a red. Okay. So now, comparative analysis. Suppose you have to see the performance. Very sadly, of course, it's a corona thing, so it's not the performance. It's actually the comparative analysis of top 10 countries affected, right? So identifying the epicenter nations using magnitude-based bar charts. You do the bar charts, and so what are the functions? Again, it is not necessary because already I have written. See, this is the bar plot. You are using the bar plot function, and now this time I'm using bar plot from SNS. That means the seaborne, from the seaborne. Okay, and these are all in one line, but I have written in one after another, because x equal to this, y equal to theta this, hue is this, palette is magma, legend is false, etc., etc. I have not given it legend. Then title, then next level, then grid. Okay, let's run it. Yeah. You see the I'm plotting it here only, so that everything is in the same place. I don't have to go from this window to that window. Okay, so quickly I will move to some other things. You understand this? I am presenting this these things. This is China is the was the epicenter. This is the, if you can see this, I can change the color, right? China, Italy, US, Spain, Germany, and then where is India? India still did not catch up. Okay, at the time it was 1920. India caught up later. Okay, so India was bad at in the second phase. Okay, so you see the data, you can present the data. Then intensity heat map. Often it is popular in geography and in biology. They always do this kind of heat map. Heat map means kind of, I mean, quote unquote, it's not the real heat. The intensity distribution in a certain way. I mean, you can see the growth. Yeah, you see this. You don't have to remember all those things. All you see the functions, figure, title, label, listing, that thing, all these things you can see. And you see there is a heat map function is there. You don't have to do anything I mean extraordinary. You see there is a function called heat map. Heat map is in matplotlib also, but you here we use the heat map from SNS Seaborn. And if you don't know how to use the heat map, where is the thing, I mean, how, what to put, you can, one is log, and in this, then you map this. It is some mapping means CMap means color map. It's a color map. Then the other things are there, labels are there, etc., etc. And then these are the usual things: title, X label, Y label, X ticks, and sometimes you have to write plt.show just to show. Okay, most important thing is this line. Okay, so top 20 time series, take the log, okay, and then do the heat map. Just see that heat map. Okay, okay. Now you see the heat map, outbreak progression across the top, and you see the color bar. You see the intensity. This is high intensity. Yellow is high intensity. This is China. Initially it was green. That means it will give you the progress, outbreak progression across top 20s. You see the Italy, US, Spain, and etc., etc. Initially it was blue. But I mean the this 00000, and then the suddenly picked up, and then the yellow. Yellow means high value. You see the from heat map, you can present your data so nice. All this fancy stuff you can see in Matplotlib, in Seaborn, in some other things, all based on Matplotlib, basically. The geospatial bubble map. This many people want to show that. I mean, often you see how it grows like a bubble. Okay, there are special kinds of map. I mean, presentations like violin map, bubble map, all those kinds of fancy stuff. We physicists hardly do, but other people which are, which we use this spatial data, like the geography people and so on, they can put this on the map of the world or something. Then you can see that. Okay, geospatial bubble map. And again, you don't see that. You recognize this figure, you recognize this plt.scatter, you recognize the title, you run X level, Y level, color bar, grid, and so on. Only thing is that somewhere there is a bubble, I think. Somewhere, I think, have to be there. Where it is, line width, and so. Let's see first what it produces. Okay, here. You see, where is the bubble? The bubble. Okay, where is someone in keyword argument? It's a bubble. CMap rates. No, it is there. DF latest date. This column, and you adjust its scale by 100. You could do it with kind of data cleaning or something like that, data preparation. But is that okay? And this scatter and this level. This alpha. Okay, so this is where did I put? Anyway, CMap rates, alpha, H colors, line width. You see the grid. It shows the grid also. It shows the shows the grid. If you enhance these things, say 8, It will show you the uh, good grid. Do I am I missing this? Where the bubble? Something am I missing somewhere? Okay, okay. Anyway, I'll show you. Okay. Anyway, and then go to images data. This is unstructured data. This Excel file is structured data, and image file is unstructured data, right? Images data. So again, matplotlib, pyplot, splt, matplotlib, numpy, everything you need. You don't need because already we have done it. And I have a picture kathmandu.jpg, and from this mat again I have from matplotlib. There is I am using another function, another module called image module from matplotlib, and I rename it mpimg, matplotlib image. And inside that mp image, there is a imread function, which actually reads my my image. Okay, the file is kathmandu.jpg. I went to Kathmandu and took that picture with my digital camera, and then the figure, the im show plot, it will show the figure, etc., etc. Let's see that. Let's see that. Yeah, this is the picture. This is the roadside. This on a shop. These are masks. Colorful masks are hanged. This is the actually picture is unstructured data, because you don't know in the jungle where the boundaries will be, where the data will be distributed, how the data will be distributed. There is nothing structured like that. So it is unstructured data. So it is image. Show the data matrix. Now I see the image this way. But if I want to see these data metrics, how do I see? I see I have actually inbred this, right? With this inbred, it has converted this img. It has this name of the variables img. Now I want to see what is img. Let's see the img. Let's see. Okay. Well, ignore all these things. Yeah. This is the image computer sees. That means it is you see the three square brackets. That means it is a three-dimensional data. That means it is basically three sheets. It is written. It's a different way. This is red channel. First is red channel, green channel, blue channel, but it is in a different way. It is showing you. But basically, the data is something by three number of pixels. And then by suppose this is the data 2456 by 3680. This is the square, and then the three these things. Okay, so total data points are this product of all those things, these numbers. That means 2,71,14,240 data points are there. Okay, so this is unstructured data. You want to just have feature extraction through slicing. Anyone telling anything?
Rothida has joined. Perhaps Rothida's microphone is on.
Oh, Rothida has joined. Okay. I'm quickly
I joined,
finishing that. I'm quickly finishing
earlier.
that. Okay, let's see that.
I just joined earlier.
Again, we don't need to see lots of. Don't need to see all those details. But you see what it is being done. You see, it's nothing but I have sliced. You see, the slicing is here. See, this is the rows, slicing of rows and slicing of columns, and I keep the third one. Third one means RGB color I have written. See, there are three axes. Normal data you have seen in the Excel sheet, the rows and columns, but you can see this is rows x-axis, this is y-axis, and this is z-axis. You can see. So I keep all these colors as keep colon. This is I want to see from 100 to 600. That means actually 599. Step size 1, and the probably in the other axis 550 to before 700. This is a slicing. So I want to see a sliced part of the image, and you see the result. This is that means we are zooming it. We are zooming these things. Now then we can do some, forget that at the moment details because I have lots more to show you actually. Okay, these files are so big, so you see this. This is the spatial distribution. You see, that's what we see in the digital image through Photoshop or in the digital camera. We see. Uh, Kishore and I know, and some other photographers here will know this. This is a spectral distributions: red, green, blue. Which color is how much? Suppose you have some unknown data from geographical GIS data or some other data. You want to see the color. Colors means something to you. Green color may be vegetables, red color may be some dessert or something like that. I don't know. I mean, some kind of colors. Colors will tell you something. So you want to see the distribution. You want to recognize the image. You want to classify the image. So that's why it's very important to have this basically frequency distribution. And how to do basically, you see, these are all, don't consider, these are all fancy cosmetics things. You plot this. I mean, here I have done it something with subplots, and then the histogram. So np dot, I have used np dot histogram. Of course, hist is there, but this will do better here. NP inside this numpy, there is a histogram function. If you don't know how to use it, okay, go there and check that. Just get the information in your head that these things can be done. So in you take in NumPy, you take Matplotlib, you take pandas along with you and proceed. You make a fantastic thing. Okay. So don't need to do all these things. And here I am doing something. I am actually making it gray. I did. Yeah. It is something what feature extraction and edge detection. So, I mean, the any machine learning thing does it better, but only with Python. But background to machine learning, there are Python programs, of course. And but here I am using Python program. All these programs are known to you, right? All these programs are known to you. All these modules are known to you. NumPy, Matplotlib, etc. And then for image seeing, it's a image module, it's a PyPlot module, etc. I'm again reading these, and then taking the product of this image with this thing, and this making it something. That's a matrix product. You see the three things: original figure, this is the grayscale figure, and this is the feature. I mean, I have to make the opacity better. I make this alpha more to see the actual outline. Okay, so basically you are going from data to some discovery. First, you have handle real data, then read the data with pandas, check the data, check the statistics. I mean, clean the data, check the statistics, plot it in different ways and see. Then apply your models, then apply your special kind of statistics, apply your machine learning program, deep learning program, whatever you want to do. But everything is done with background Python is running. So if you know a little bit of Python, it will be extremely useful for you. Okay, I want to show you some visualization plot. Let me show you this, the data. Suppose I am creating this data, right? Okay, at the moment, just tell me before I move into some more to show you. Please tell me if anything you want to ask within my knowledge, actually.
I have one question, Abhijit. What do you mean by age detection?
Age detection, yes. Age detection is done. Actually, you see, it's a part of image processing, and the age detection cannot be done very nicely with Matplotlib, of course. Matplotlib image processing library, of course, it's not can be done so well, but the ordinary works you can do. But of course, if you want to detect a tumor, for example, Rothida will tell later. So of course, for that you need, of course, from a CT scan, of course you need machine learning program, deep learning program, of course. But for a for general pictures. I mean, you cannot, something is hiding, you cannot see it properly, but you can actually make the contrast something some way, or some make the edges, try to understand. This is here, it is that is very crudely, and all these things are basically matrix multiplication. You have your image is something by 3. Suppose 2956 by 39867 comma 3. So it's a basically a 3 matrices in a box. This is basically 3D matrix, or a box, or a tensor, you can see, of course. But you have to convert this. Suppose you have want to make it in a grayscale. So you product with a 3 by 3 matrix. So it's basically matrix product. You make it to something sepia tone, you make it a product. So agitation is also, I mean, here doing a product with something, some other matrix. Okay, so that's very crude here, but of course, very common things you can do, very normal things you can do, but not very precise things you can do. Okay, maybe after the end we can talk more on that. Okay, so data visualization. Okay, suppose I am creating a fake data. I want to now show many different kinds of data visualizations. I have shown you with real data, but now I want to show something. But I mean, real data is sometimes hazardous because you have to clean it, you have to understand with data frame and so on. But we suppose we understand better NumPy arrays at the moment. Suppose NumPy arrays are easy to understand. So here I am creating some noisy some signal. Okay, so let's say X. Say Ornabada told that np dot lin space. This is a linear space. It creates data from 0 up to 10 and 100 data points. So now, and then this is an array, right? This is an array, create array of numbers between 0 to 10 and 100 data points. So the divisions will be generated by 100, 10, actually it will be basically 100 data points means it counts from 0. Actually it will be by 10 by 99. So it will be something odd like. Better you can put it 101, so that maybe it will be division by 100 intervals. Okay, but if the 100 data points means 99 intervals, so the division will be bad. Okay, anyway, forget that. So you are creating some X array. So the X points are uniformly spaced between 0 and 10, 100 points. Now you use this np dot sin x. Is a sine function, okay, and it is taking this x, that means x array. And I told you that all the mathematical functions, everything in NumPy is basically vectorized. That means the sine function will be applied on each of the points on x. Okay, so this is basically sine function. You can take this and plot it. This is a sine function, and on top of it, I have put some noise. That means I have created some noise. np.random.normal, already have shown it, based on mean 0 and standard deviation 0.2, very small this width, and 100. Of course, here is the 100 points. Here is the 100 points. So just add it, show it. Suppose it is your data. I mean, just for fake, it's a fake data. Okay. And you see the print use y colon 10, right? So you see that means you start from 0. I mean, the first data, you go up to 10. 10 is the stop. That means 0 to 9. That means first 10 data points you can see. But suppose this is your data again, and you do not understand what this data means. Of course, first thing you want to do is that you want to plot. Again, I am starting from the beginning, and then matplotlib. Yes, I want to show you how many different kinds of plots you can do with this. And then you plot to see, do the scatter plot, do a scatter plot. You see this sine curve is distorted because if you have a kind of data like this, you will immediately understand maybe this is a sine curve, maybe this is a distorted sine curve. We can feed the data with the sine, some sine function or something like that. Maybe there's some oscillation is going on. Anyway, so okay, now this is scatter, and then oh, of course, my favorite is dark background. I want to see this dark background and again see the scatter data. Oh yeah, see it looks nice. Nothing. It is a just cosmetic surgery, and this is something with Python. You can do this fancy stuff, matplotlib, and you create another something exponentially. Suppose you use NumPy functions. It's an exponential function. You see these exponential functions np.exp. This is the t time, suppose, and np, that means e to the power minus t by 3 into something, cos of 2 into pi into, this is pi, right? np.pi into t, and you add some noise, random dot normal dot this 200 points here, 200 points, and again add some noise, and you see the ugly data, and again see ugly data. Now, why I want to show that, just want to demonstrate. I call it artist's palette. That what I was doing actually at the time. This is a bare minimum thing. I have not put Y level, X level, title, legend, arrow, nothing. Now I can use all those artistic things. That means, see, you have plt.figure. The figure means it's a function which controls the size of the figure and things like that. Go to help, okay, write help, and inside that write plt.figure. It's a fixed size 10 is to 10, 6. Then plot t versus data. Okay, t versus data. What is data? Data is this signal plus noise, suppose. Okay, and then I could give it color as red or something like that. I have used this fancy stuff. This is the color code. You can go to Google and check all these variations of all these numbers, and these things is written in hexacode, right? Color hexacode hash, and then some zeros, A, B, C, D, etc., etc. All these things. You can create very many different kinds of continuous colors. Like in a painting, when you do your home painting, you go to these shops and check all kinds of variations of colors. Here you can manually do all these variations of colors. This is, you don't write red or green, or this is a specific cyan or magenta or something, but you can use these fancy things that is your control. You can create your data visualization with all those hexacode. This is you don't have to remember. You go to Google and check hexacodes for colors. It will give you all these lists. You can then vary a little bit and create different kinds of colors. Then line width equal to 2. All these are actually keyword arguments. Color is a keyword argument. This is the normal argument, right? X and Y. This is x-axis, this is y-axis. Then this is no keyword argument, line width, then level, sensor data, etc. And then the title, X level, Y level, grid, legend. And again, inside everything, X level I have seen, right? The X level I have given written time seconds. And then size equal to 14. That means it's a creating the X level is 14 size. And title font size is 16, color cyan, Y level font size 14, and line style here, grid line style here, alpha here, all these things are here. And then also I can put, since I have given the label here, and where to put that label, I have to put write plt.legend and see the result. See the fancy stuff. So this is the title, hidden signal revealed. This is the, this is the, let me show you this way. This is the y-axis, this is the x-axis, and this is the legend sensor input. You can make it, suppose you can make the font size some 20, you can make it some 18, then you can make it some 18, change the color, this thing, that thing. You can see, of course, of course, see, you can see the, this is, this y-axis, x-axis. Then you can put lots of uh, parameters you can set. Then you can do lots of stuff. You don't have to see all those things now at the moment. Yeah, you have this data, and on top one function on the these things, two legends, all kinds of things, because these are two plots. One is a discrete plot, one is a continuous plot. All you can do, because if you see this, you see one is scatter plot and another is normal plot. You can also plot this way. You can also create subplots. There is a function called subplots. Also, you can create with this, or also you can just write plt.subscatter, plt.plot. You can also do that. Also, you can create plt.subplots, and inside that, subplot is another function, right? So you will learn by seeing what people are doing, where the examples. So it creates the figure about the axis. So in the left side, you actually separate them. Okay, okay, and then you see the things, and you see the next one. You don't have to read all those code, because it's not necessary. You see, you can give an arrow. How do you see the arrow? You know how to give a title, how to give axis, this thing, that thing. How to give an arrow? Of course, maybe there is a function called arrow. You see, of course, there is a function called arrow. Oh, there is a function called, I used arrow function. Plt.arrow function is also there. But here is a function called annotate, and lots of things that you are adding with axis. Annotate maximum amplitude, xy equal to this, where from it starts, then text, then arrow props, and then arrow color, face color, how much it will shrink, font size, etc., etc. All the features you can add. You don't try to remember. When you check, you can check individual function. You remember only two mantras: dir, with which you can see a directory, you can see a module or a package, and then help. We can see the function. What is the manual of the function? That means how you will use the function. Just take the function, use it, and try to use new features, and your graph will be beautiful. Okay, one day you cannot concentrate on so many things. Then there is a subplot. You see, there is a function called subplots. In my earlier lectures, I used to use normal plt.subplot, but here I have used subplots. Okay, you have a space, you create this figure, this figure, this figure, this figure, all the plots together. Okay, so create the spaces, either one or two, or four or three. Suppose here I will, let's see what I've done. Yeah, I have actually used this two plot. I will actually plotted these two side by side. That means you have this is space is 2 by, one row, two columns. That means 1 by 2 space. You'll see all these signatures here. See, subplots 1, 2. That means you have created 1 by 2 space. Fixed size is this. Then one is axis 1. This axis 1 is hist, and then axis 2. This is plot 1. You see the plot 1. If you see my this thing, you can understand it. This is plot 1. This is plot 2. These are the features of plot 1. These are the features of plot 2. And later I have written plt.tight layout. That means too tight side by side. Otherwise it will be separated and it will look bad. So these two plots are side by side. This is a subplot. Okay, you can create fancy colors, you can keep fancy representations. And next I will plot 4 things. Sin x, cos x, exponential, and random normal, these things. Suppose these are your data. fake data. Okay, and you now plot the four things. Yeah, you see the. I mean, unfortunately, I cannot show you all together. Uh, oh, it is two. It is two only. It is two only. Next, it is four. There are four. Next, it will be four. It is actually working. So you can plot many plots in one graph. You can plot many graphs in one same space, etc., etc. So here we have four plots. See, one sine function, one scatter plot, one bar diagram, one exponential thing. So all these four things you have presented. Okay, so you can plot it in a separate window, but I'm not going taking this trouble anymore. But because I have to go from this window to that window every time to show you. Okay, so this is what you can do with Matplotlib. You can your data, and okay, now. Okay, what I've done, I forgot what I've done actually. Let's see what. Yeah, these are the two plots, and in the same axis. You can also do that. The axis is the same for this and that, one top of the other. Okay, so this is actually 2 by 1 space, 2 rows, 1 column. This is a subplot also you can do, and you can actually write this percentage matplotlib what actually take you the figure out, and when you are using actually 3D plot, I am actually for using I'll be plotting here 3D plot. Okay, so from along with numpy, along with matplotlib, if you write mpl underscore toolkits dot mplot 3D, if you import this axis 3D, it will help you make 3D plot. First, you have to take x-axis, y-axis. You have to create a grid. What is 3D plot? You have a grid, and on each grid points, you have z-axis, the upper. Okay, so that's what you have created a grid, like a graph paper, and then it is a capital X, capital Y, and then you something like you are plotting np dot square root. That means square root of some values. Okay, these are the these things, and then sine or inside the sine function. So z is inside sine function. That means sine of you are plotting actually sine of root over of x square plus y square. So that is the z. So you have something like this. X-axis, this is x, this is y, and z is on all points. Z is this. Okay, values of x and y's. Take these, square it, sum it, square root it, and then sine. You see how it looks like. This is not a real data; it's a fake data. Okay, but I want to see how it looks like. If you do this, yeah, it is doing. I will not plot outside, I will plot here only. Okay, and see this. If you plot it outside, then you can drag this, and you can rotate it. Since I don't have time at the moment, I am not going to show. And this is the color bar. It will show you the intensities. That means z-axis ka these things. You see the color here. And you can control the color screen, all these things, right? You can, again, the same thing. You see, this is axis dot plot underscore surface. It is a surface. You can create a wire network. You can get surface. You can create this color bar, and this CMAP color map is Coulomb. This is Coulomb scheme. This H color is none, alpha 0.9, etc., etc. And you create these things. First, you create capital X, capital Y, capital. That means these are the mesh. You create the mesh grid with NumPy, and then Z values, and then these things. Axis you have already created, because first you have created axis here, fig dot add subplot, fig dot figure, plot dot figure, then plot surface. Inside that, you are plotting actually with this function x, y, z, and all this. Okay, so this is your 3D plot, and this is another. This is another. Yeah, this is the same thing. This is a 3D plot, and this is a contour plot. Imagine this is the contour. This on the mesh grid. This is just a contour, and on the contour, you are actually going third direction. So this is this. Okay, on the perpendicular to this grid, and all those things. Let's see what I did. Or lots of things, but you don't have to remember anything. I'm telling you, this is not useful to remember anything, only what you need. These are all fancy, these things, professional plot of kind of real. These data were, I'm not created, these data were actually, I have taken from here. Yes. Oh, it is actually Gaussian. Yeah, no, this is a fake data. This is another place I have actually used that data. This is a fake data. I have created some complicated function, okay? And I tried to plot this professional looking contour plot, okay? This is a continuous one. This is the discrete, I mean, this is a line ones. You can create the left side, you can create the right side, whatever you want, okay? So you want to see the actual lines, you plot this way, you also plot this way. Both side by side with the subplot, with the color bar, etc., etc. You can do lots of things. But maybe at the end of the day, you may be confused because so many things are happening together. But the fundamental thing is that when you go back, you just get to know that all these things can be done. This is some stuff. This is nothing. This is something, some distribution with the histogram, you know, plt.hist you can do, and with the functions you can plot. Okay, and this thing, let's see what it is that I did. Oh, 4 different experimental groups, and this is this. These are all these fancy bars. You can outlier analysis, etc. This kind of things also is important. Generate correlated data. This is another fancy stuff. You often present correlation data like this, but it is a very fantastic presentation. You see, this is on this side, this one, the ISCA distribution. This is on the y-axis, these things distribution, and this is the correlation plot. Usually we see the data, or usually we see a scatter plot or something like that. But here you see, I was showing you this fancy stuff you can do. One side this, one side that, and then this is pictorial presentation. All these things you can do. Okay, let's see that. It's another, this is a pie diagram you can do. Plt.py is the pie diagram. Okay, and all this fancy stuff you can do with switching. Just take the keyword arguments and can change all those kinds of things. Well. Let's see. Actually, lots of heavy stuff. I mean, don't remember anything. Again, I'm telling. Okay, doing. Let's wait. Okay, done. Yeah, it's very professional looking data. You can, I mean, forget about all those details. But these things can be created. This vector field can be created with arrows and everything, with all different functions and with keyword arguments, functions and keyword arguments. This is a polar plot, probably. This is a polar plot. This is a kind of scatter plot, dense scatter plot, and this is a vector field. Often in physics also we want to do, in geography also we want to do this. These are all fancy stuff you can do. Okay, and anything I did, what I did, let's see. Yeah, lots of stuff. Actually, these things you can do lots of things. All these in these presentations I showed, im show with this and this fluctuations. These, I think this will be the end of this, and yeah, yeah, all this stuff, all these different kinds of presentations together you can do, and finally you can, yeah, it is sound file. It's a sound file, sound intensity distribution, etc., etc. And now I'll show you one fantastic thing. This is a function animation. You see, this is a function animation. This is a, you can see some light source or it's a pulsar in astrophysics. All you can do with Python. Suppose this is now static. It will create. Okay, where? No, the next. I think the next one. I think the next one. That. I'll show you a dynamic one. I'll show you a dynamic one. Animation. It should show you the animation. No, it should show you the animation. Why it's not showing the animation? Animation. It will show you the animation. No, the next one. Right. Lots of things. Ha. Actually, with Python, you can also create some GUI, graphics user interface. That means something called some kind of widget in Python. Okay, so that you can control the widget, control the GUI, and check all those things. Okay, let's see the next one. It will show you the actually these things here. A little bit of HTML and these things have been used, but forget that at the moment. But only thing is that it can be done. That's one thing. This is something. Suppose something is animating. This is animating, but I will show you even better things. How you can control that. Okay, this is also actually this is actually showing actually. Yeah. Forget it. It's a big file. Okay. I can stop it. And I can. Acha, I'll stop in 5 minutes in time. But before that, you can tell me whether there is any question. No, it has done. It is done. Now it will show. I'll show you these things. This is fantastic thing actually. Yeah. Before as by the time it comes, tell me please if I. Okay, Rothida is going out for a meeting. I have a question for Abhijit. If you can send us a response, we will send you through WhatsApp. Yeah, please. What is the question, Rothida? You have not asked the question. I don't know what Rothida asked, but maybe. If anybody has any question, please tell me. I think already overloaded by so many things. Let's see. Okay, it will come. It is running actually. This is actually this so much of things. Okay.
Actually, Abhijit, you have covered a major part of the machine learning. First,
No, it is.
you
It is.
have
No, I
no,
have
you
not used
actually
any. I have not used any
no,
machine
no,
learning.
I know. But the basic steps towards machine learning is
Ah,
first loading the dataset, then cleaning the dataset,
okay,
and
okay.
then visualizing the present data.
Huh.
So up to this is the step by step towards machine
Yeah,
learning.
but it
Huh.
is so. I'm actually moving so
Yes.
rapidly because I wanted to show so many things. But please wait for some more minutes. I'll show you
Actually,
some. I'll
next
take
part
another five
is
minutes to show you another
actually
some fancy stuff.
next part is exploration of the data file
Mm-hmm.
and testing and predicting the data.
Yes, yes,
So the
that's
rest
what
part
we'll
is
do because our another speaker will do because machine
yeah,
learning
yeah,
part means one has to she will use the uh, mm, model. She will take the data,
yeah,
train the
yeah, yeah.
data, test the
Modeling,
data, and then
ah,
use the network,
modeling
neural
the data,
network to predict
neural
things.
network.
Here, nothing to
Right.
predict. It has just data,
Yeah,
handle
yeah.
it,
But
clean it,
basic
display it.
basic steps you have done. You have
Yes,
three
yes,
four basic
yes.
steps.
Yeah, but I mean, in one day, I believe it is difficult for one to remember everything and things like that. See, this is a fantastic stuff. See, this is the widget. I have created this. Is this there is a module called animation? Okay, with that animation, you can do some animation. You see later. So this is the say pulsar, for example. This is a fake pulsar and is oscillating, blinking, and it has created the widget. Inside this Jupyter notebook, you can create the widget. It's a fancy stuff, right? I can a little bit, uh, yeah. See now you run this. You see fantastic presentation. You see the pulsating things, you see the pulsating things here and the sine curve corresponding intensity, this average brightness of the figure. Okay, so these things are very important for our demonstration in the class also, in the physics class also. It's a very fantastic thing. Okay, I'll show you one. I wanted to. I'm tempted to show you one nice thing about uh, in I have created one double pendulum. It's easy to create. I mean, you use the equations and things like that. Let's see quickly. I'll show you. Don't try to guess the programs. I mean the codes, but I want to show you the fancy stuff here. Just first, people who are in geography, I'm not using any GeoPanda because GeoPanda is a huge package. I did not load here because I don't want in work in geography. So without GeoPanda, only I use this Plotly module, Plotly package. So there are three fantastic visualization packages in Python. Many people use. One is Matplotlib. Based on that, you have Plotly, you have Seaborn. I have used Matplotlib and Seaborn. Here I am using Plotly just because Plotly is another fancy stuff you can do it, and also animation you can do. So run it. You see. So and the data is taken from this Plotly. Plotly itself has a demo data. So data I am taken, geography data I am taken from Plotly. Plotly is a store of data like scikit-learn. So here you have seen, you see, this is a data frame. Okay. And so you see, oh, so this is a data frame. Okay. 1704 rows by 8 columns, etc., etc. And try to see the plot. Try to see the plot quickly. I'll just click and within 5 minutes I will finish. Please hold on. This is a geography plot, and you see the it is plotting on map, and the map is interactive. I can actually by the scroll of mouse, I plot these all the bubbles here, and I can see these things. It is automatically done. It's very useful for geography people, but later they will use kind of GeoPandas or GeoPython, ArcPy, and etc. etc. They will do lots more fancy stuff. But with only with Python knowledge, and also that is also written in Python, you can do that. So it's a mapping without GIS. Let's suppose this. Okay, and here also you can do the same thing, but without on the globe. Or here you can see, you can with the scroll of mouse, you can increase, decrease. It's an interactive map, and then you plot things on the map. Because without map, geography is nothing, right? This is a very the heart of geography is map. Then see sociology. Understood that there will be people from sociology, so social science, there are people from geography, people from biology, people from physics. So for each one, I have done something, and again, you are using this. But just wait. Seaborn, I'm using Seaborn, Matplotlib. This is running. Star is there, so it's running, and you metrics of human behavior. You see, it's a correlation matrix, but you see the presentation is so nice. I mean, you can actually, I mean, given this data, given this metrics, correlation metrics, and with the color bar, you can actually motivate people. The pulse of the people. Okay, let's see the pulse of the people. Yeah, these are these stuff. Biology, distribution of life. Don't want to know I mean, what is happening here. And it's a violin plot. It's a biology people use that. Okay, people who use biology plot, violin plot, they know. But I don't want to. These are the some data taken from these things. This scikit-learn is there. Iris data, this thing, that thing. All kinds of petals, sepal length, sepal width, and all kinds of petal length, petal width, all kinds of botanic data, and visualize on variance on these things. Yeah, and yeah, you see the fancy stuff they're doing. I mean, this previous like this one is the blue color is setosa, three kinds of different kinds of flowers: setosa, versicolor, virginica, etc. Species, three species, and this is sepal width versus sepal length, and this is the contour thing on the three different species and the three distributions on two sides. So this presentation is something like it's a fancy, right? This presentation is fancy. You can do lots of things. And with Plotly again, I can actually show you another these things. And you can see this is a dynamic thing. Again, I have created a widget, and you see the growth of this actually geography again, global development. You see the life expectancy versus GDP per cap. This is a geography one again. So you can see these small fancy stuff, these animation stuff. You can do that. You can create widget and you can show that. Another 3 minutes. What is there? Oh, membrane potential, etc. etc. Oh, this is a pulse again. See the biology again. Function animation will take time, but anyway, I want to show this physics stuff. One little animation that is my favorite. Wow, yeah. Wait. I could better keep it here. Uh, it is actually running. It's very slow because so many things are doing. Yeah, done. Oh, this is the thing. If I now do it, you'll see the pulse is going. You can see the it's basically nerve pulse. It's a very fake data, but you can see it's like a ECG curve or like a CRO. You can see you can create this sine curve moving. Okay. But now finally, I am going to double pendulum. Everybody who studied physics, elementary physics, they know it's a double pendulum. You have a bar and you have another bar attached to that, flexible, and this thing is moving. Okay, and these creating some lines. Normal pendulum, it creates some fixed line, right? This curve. Okay, and but in double pendulum it is really chaotic, so it will show you that thing. This is the last one. This is the last presentation. I'll show you this. Just wait for to happen. I mean, this program is nothing but you see NumPy, Matplotlib, SciPy. You need to solve the differential equation. So ODINT is there. This from matplotlib.animation you need function animation, and for the finally to present as a widget you need this ipython.display equal to from import HTML. You need this for widget. That means this GUI interaction. Okay, just wait for maybe 1 minute, and that will be the end of my lecture. Okay, just I'll show you that and finish. Well, By that time, you can ask question. By that time it is happening, you can ask any question. Any question or no question? Any question or no question? Okay. Will you ask question? Anything?
No,
You can write
actually, I have
in chat
actually,
box also.
yeah, yeah, yes, please.
Yeah. Yes. Please tell me. Anything? Anything? Okay. Another.
Somebody was asking some question. I think
Please tell me. Please tell me. Recite it for me. System load
somebody
is heavy
was
actually.
asking.
Somebody, my system load is heavy. I have not cleared all these things. My because I was actually looking at the demo and I did not care to remove all those things. That's why it is so slow. I'm sorry. Otherwise, the talk would be over by now. Yeah. What is the question? Any question?
Sir, this
I
is
mean,
Swati Ghosh.
yeah. Tell me, please, if there is any question, please.
Sir, sir, thank you for the nice presentation.
Okay.
So I have seen your last presentation in BKGC College. So after
Yeah,
that, I have
yes.
tried.
Shati, you were speaking.
Yes,
Okay.
sir. Yes, sir. I've
Yeah, yeah,
tried a
yeah.
lot many things. One thing is I am not able to save what I have done. Right? I means I can
Figure.
show
You cannot save the figure.
figure or I cannot
Oh,
export the
yes,
figure.
saving figure. There is a function called save fig. But apart from that, you just
Save
right click the. You
notebook.
don't need. You right click the graph, and then it will come save as. Okay.
Okay.
Any graph,
Yes.
any graph. If you click a static graph, for example, suppose you have a static graph. Say suppose you right click and then you can. This not showing anything.
No,
Here
it's not
the earlier
anything
it used
like.
to show this. Earlier it
How
used to
you're
show, oh, because there's
exporting
a
this graph in a
new
PDF?
Jupyter notebook, they are showing something different. I'll find out until there is a function called plt.savefig. But earlier old this Jupyter notebook that I showed in on offline in the Vijay Krishna
Huh.
College, there I had the old these things. There just by right click you can save it in the figure. Okay, but
Okay,
I'll see it and post it.
I'll search, sir. Okay, and sir, can you please suggest that when we are giving any uh, like any prompt or any means like PLT, what you are saying that you have to write like this and this, and then when it is showing that some error is there, means I'm not
Mhm.
able to figure
Error
out
plot.
what. No, any type of error means any
Ha ha ha
if it is showing any type of error, syntax error or any type of error,
ha ha ha
I'm not
ha.
able to figure out what error is there. Means I'm not able to understand what it is. Means is
Oh,
there any means
okay.
I can show you. I can if you give me the
Yeah, if
permission.
you
I
could present that. I mean, the error, I understand that the error, I mean, I can guess your thing. Error is a specific thing for your own problem. For your
yes,
problem, people have encounter different kinds of errors. Suppose you have, if you have some error or you want to calculate some error. If you want to calculate some error, of course, there are functions, and you can write a one-line code also, or you can calculate with some from the data you can calculate. Okay, there are lots of functions in Python in NumPy with which you can find different kinds of calculate different kinds of errors. This is one thing. And the if you want to present the error bar that I was showing, it is a function called error bar. Okay, with that I can uh, uh, you can plot the error also. I mean, actually, I am not able to hear much in this new. I mean, my machine because the volume is so low. Somewhere, I have to fit this. Okay, I guess that is your question. Okay,
no, it's okay,
oh,
sir. I will try. I will try
you
accordingly.
send me. Yeah, yeah. We'll talk in.
Actually,
in
lots and
short.
lots of errors and errors and problems are coming. So
Yeah, yeah, yeah. But the errors are very important. I'll show you. I'll show you actually. I'll
One thing,
talk
one
about
thing
it.
I must mention, Abhijit, the one thing what I do in my case, I copy the error code when I do not find the reason why error is coming. I paste it in a Google. I paste
Huh.
it in Google. They will Google will reply you, oh, what kind of error this is. So this is one way to find out which error it is.
Yeah, yeah, yeah. Google AI. You can go to AI and check with any broad AI,
we
ChatGPT,
can
and all
take the
other things. You can
assistance from
ask.
Anaconda itself. We can check the error from Anaconda itself. But when it is
Oh, error
hundred
from
percent the
Anaconda.
chat,
Oh, that means this is
yes.
a.
But
I mean, writing this Anaconda is giving some error. No, that.
no, we can chat in the Anaconda assistant. It is
Oh,
there.
yes, 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 yes,
But
yes, yes,
when
yes,
the chat is 100%, it is not allowing you
yes,
to
yes, yes, yes,
chat
yes,
anymore. So
yes,
this is
yes,
a
yes.
problem.
Sure, 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 sure.
Madam,
Hmm.
you can take opportunity to any AI tools. It
Yeah,
will
yeah,
help you.
yeah, yeah.
Yes, yes, that may help. Right. Thank you, sir. If I face problem, I want to share with you so that means with the permission you have given me already, I'll share the screenshot of the error so that you could help me.
Okay, okay.
Actually,
Okay,
I
maybe
have.
this is not coming, so
Uh,
maybe I end that. Maybe I.
actually, actually,
It's
I
not
actually I
second time,
have
so maybe
more than
I can
100
use it.
questions right now, but this is there is no time to ask these questions. So let us stop right here.
Yeah.
I think.
Okay, maybe
Namita?
sure. Okay,
Ha
okay.
ha ha
We should now stop because this thing
ha
is not.
ha.
It's slow. Unfortunately, I have not cleared all this stuff.
No, 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 no.
Uh,
It's okay.
anyway,
It's okay.
later I'll show you. Hmm.
Very interactive session. I must say.
Actually, we were
Thank you. I
actually we
wanted
were
to show
over.
this just the visualization thing more and this real data, what you can do with that. But it's not model. It's just display and take little bit of out of it, and that's it. Okay.
Yes, sir.
Okay, thank you.
Uh,
Thank you. And individual, if you have questions for specific things or specific subjects like geography, like Shati told, and other biology particular problems, and you are facing something problem and trying to do understand something, I can at least suggest from my some own experience of what to do. Okay. Uh, thank you.
Sure, sir. Thank you.
Thank you all.
Thank you, sir. Actually,
Ha.
we are over enriched today, I think. Uh, so, hope we have had great discussion today. Thank you, sir. Thank you so much.
Thank you. Okay. Okay.
So, can
Okay.
we conclude today?
So let us end the session. Okay. Thank you.
Okay.
Thank you.
Okay. Good
Okay.
night. Good night,
Mhm.
everybody.
Mhm. Good
Okay,
night.
okay,
Good night.
good night. Sorry. Bhagwan.